State Physics Outreach is a group of science students learning to teach science. So here now is Don Williams, the professor behind the Traveling Student Scientist Group. And today, we're going all science today. We're talking about the Meissner effect.
That's one of them.
And the superconductors.
Right, and quantum locking. Doesn't that sound pretty cool?
All above my head. And
I tell you, maybe not,
I
though.
feel like
Maybe
I
not.
should wear these.
Yeah,
right?
You're going to need them because that's the first thing we had to do, Emily.
Okay.
We're going to be talking about superconductors.
What's a superconductor?
A superconductor is something that conducts like no resistance, okay? You know, most of the electricity that goes through our power lines is just wasted. It just goes off as heat. Almost all of it.
Okay.
Yes. So you're wasting it.
Okay.
A superconductor has no resistance, and the current just goes through with no loss.
All right.
How beautiful that is.
It sounds beautiful.
It is.
Explain it
But
to me.
Here's our problem.
Okay.
We need to get our superconductors really cold to make them work right now.
Okay.
Okay. But I've got a couple of superconductors in here that I've put in liquid nitrogen. Okay. And I'm going to get them really cold. Let's get these tongs. I can do a little better. And there's a small one. Okay.
All right.
I'm going to put it back in there. I'm going to show you in a minute. I got a big one too. And they're actually encased in plastic. They're inside there.
All right.
But at first, we're going to start over here.
Okay, what's over here?
That black one there, you see that?
Yes.
That is a superconductor. That's not a magnet. That's a superconductor.
Okay.
Now, we're going to get that really, really cold by pouring some nitrogen on it. I'm going to take a little bit out of here. Okay, we're going to get that kind of cold. Okay. Now it's going to become a superconductor. Now, Emily, I want you to take those plastic tongs.
Okay.
And now you're going to grab this little baby magnet, and you're going to try to set it.
Oh, that is a tiny little magnet.
It's a tiny little magnet. You're going to set it kind of right in the middle, and let's see if it'll levitate.
No, I'm kidding.
Okay, about right there. Let's see if it levitates there. Okay, we got to get it a little bit.
Okay, it's not cold enough.
We got to get a little colder. Let me pour it up. Let me get a little colder. Okay. That's our problem, right? Is we have to get the superconductors
They have to be super cold.
See, that's negative 200. We're getting that Celsius, right? Give it a try.
That'll wake you up in the morning. All right, you think now?
Set her in the center there. I think it's ready to levitate. You just kind of let it go easy. Now lift it up a little bit when you set it. Lift it up just a little bit.
I'm doing operation.
And there you go. There it goes.
Oh my goodness! Look at it.
You see it? Does the mirror look good, guys? Yeah, I see it in the mirror. I can see it on TV.
Oh my God!
You see that?
Yeah.
Now you touch it and make it move a little bit. You can get it to rotate. Look at that. Look at that, Emily.
It's floating.
And they can see it on TV.
Okay.
It is.
Okay.
It's levitating. All right, now what's the physics, huh?
Yeah. What's the physics?
Physics is one of the effects, that Meissner effect you said, is that it expels magnetic field.
Oh.
So if you put a magnet near it, it says, get that magnet out of there, so it levitates the magnet.
Look at it go.
Isn't that cool? Now try the round magnet. Let me take that one off.
Take this one off?
Yeah, just set it off, and there should be another little round magnet over there.
I think we lost that one.
Did we lose that right?
It's right here.
There it is. Well, there's your little round magnet. Now see if you can set that one on there, Jen. It'll levitate too. Now remember, this is the Meissner effect, and this is a certain kind of superconductor. It's actually composed of a lot of different atoms. Look at that thing. You can see that on there. Great idea AJ had of using that mirror, huh?
Oh, that's crazy.
Perfect, isn't it? Now that's our baby one.
Okay.
Right? That's our baby one. We like to start with that one. That's kind of small.
Okay, well, now what's this big one?
Now let's go to the next one here, okay? Now these are magnets again.
Okay.
Now I'm going to take my medium-sized superconductor that's actually encased in plastic, and I'm going to set it up there. And I'm going to let you touch it even.
With my hand?
Yeah, you can. It's just cold, but not super cold. And just kind of spin it a little bit with your hand or that. And you can see how it'll spin too. See if you can center it on there.
Oh.
You can touch it. It's just cold. It's not super cold. There you go. Tilt it up.
I have that thin Central Valley blood, so
you see that? Now look how how that's levitating?
Yeah, it is levitating.
Okay, now, and you see how it spins, right?
Yes.
That's still the Meissner effect. Now what I'm going to do is I'm going to take this over here and I'm going to do the same thing. Now look, I want you to try to spin it with your fingers and feel it.
Oh.
Do you see how it just turns?
Yeah.
This is our quantum locking. You turn it and it stays there.
What does that mean? What does quantum locking
that is
mean?
another level of superconductivity, another mechanism that goes on. Quantum locking. It's pretty crazy to get into the explanation. So that one there, you see how it's...
He's like, you wouldn't understand.
Yeah, it's pretty... Well, believe me, we don't even as physicists totally understand. Now we're going to our really big one to demonstrate this now.
All right.
Okay, now what we've done here, Emily, is we've lined up a whole bunch of really strong magnets.
All right.
All the way around, so we have a racing track now. Now, we're going to pull out the big one, the big superconductor. And all it is in case the superconductor's inside, it's encased in plastic to kind of keep it cold. And watch what I'm going to do here. I'm going to get it on the edge here. Let me see if I can get it up level. And I can get it going.
There
around.
it goes. I
Check
think I've
that
seen
out.
you do this before. Okay, what exactly? So you said
So
the
now-
superconductor is in plastic.
Exactly.
But what is the superconductor? Like,
It
what
is like
actually is it?
It's nothing more than different atoms. As a chemist,
Oh.
that's one of my colleagues, Pei Chun Ho.
Yeah.
She's working on different chemistry to combine different atoms to make molecules
Right.
that are superconductors.
superconductors.
That do this type of principle.
What
Exactly.
would we
now, go ahead.
apply this to in the real world?
Because we could have all of our wires have superconductivity, which would mean we wouldn't lose all that
No
power.
loss of energy.
Plus, how would you like your car riding around
Yeah,
on something
that
like
would be
that?
s- that'd
See,
be
if you
sweet.
embedded them in the road, you wouldn't see we lose so much stuff through friction.
No
This is
potholes.
like frictionless.
Okay.
Now, do you think I can do this upside down?
Yes.
Yeah, because I said that, huh?
Oh.
Now, let's see if I still can. Let's see if we got it cold enough here. Let's see if I can get it back up underneath here like
Oh,
this.
yeah. I have seen
There
you
it
do
is.
this one before.
Yeah,
But it's not. It's losing. It's
Yeah,
a little
it's
warm in here.
It's getting
so
warming it up, exactly. But you can see it. It's hit the stand over there, huh? But you can see it wants to grab that thing. There it goes.
Yeah. So that's
Yeah.
that is a
So
great
it's-
demonstration
yeah.
of power.
It's locked it in at a certain level, this quantum locking,
Right.
just like here. So this is one more level of understanding of superconductivity. And believe me, we are learning all kinds of things. But if we can make them that don't need to be cooled down like this,
Right.
there will be tons of applications because we lose energy through all kinds of resistance.
Right. Okay. And so the study of what this superconductor is, that would be chemistry.
Yep.
But the study of how to harness the energy, that would be physics.
Well, physics would be both of it. See,
Okay.
remember how physics is the granddaddy?
Okay.
Right? See, we've got into the chemistry now
Yeah.
because we look at the quantum nature of chemistry. See, we took chemistry to a different level in physics.
Yeah.
You've heard of quantum mechanics.
Sure.
We took it to a different level, and it's beautiful, actually, what we do with physics.
All right. Well, I act like I understand.
You understand a lot. I know you
I
do.
always learn something new when you come with us. But
Exactly.
you brought along some of your students, and you brought along the head of your department.
Exactly.
He's checking in on Don over here at CVT. So thank you for being here. Everybody else, stay right there because we've got more physics when we come back.
Very